Welcome. The objective of this learning module is to define what process capability is and help you understand the difference between process capability and process control. At the end of the measure phase, once we've collected the data, what we're interested in is whether the current state process is a good process or a bad one. So what is a good process? A good process must be able to consistently deliver an output, whether that's a product or a service that meets the customer requirement. This means that a good process must be two things. Firstly, it must be in control to deliver a consistent performance. And secondly, it must be capable to deliver a product or service that meets the customer specification. It's important to understand that process control and process capability are two completely separate characteristics of a process. As illustrated here in the diagram, you can see that a process can be in control but not capable. In other words, it's consistently delivering something that does not meet the customer requirements. Or you can have a process that is meeting the customer requirements, it's capable, but it is not in control, it's not stable. Or indeed, you can have a process that is both out of control and it's not capable, in which case, that's an obvious starting point for improvement. What we want to get by the end of our project in the improve phase is a process that is both in control, it's stable, and it is capable. You'll remember from the e-learning module on statistical process control that a process is in control when the amount of variation in the process is consistent and predictable over time. In other words, the process is stable. Just some of the benefits of a stable, predictable process are listed here, and one that is particularly relevant in relation to process capability is that you must have a stable process before you are able to measure and improve process capability of the process outputs. That's why we check stability on the measure phase roadmap before we check capability. So what is process capability? Process capability is broadly defined as the ability of a process to satisfy customer expectations. Some processes do a good job of meeting customer requirements and therefore are considered capable, whilst others do not and are designated not capable. To achieve a Six Sigma level of quality, as we've said, we need processes that are both in control and capable. The concept of measuring and reporting how good our processes are is, of course, not new. Many processes already have measures in place to assess their ability to meet specifications. The most common approach to measuring process capability is simply to measure the percentage pass or fail rate for the process. However, what is often less well understood is that simply counting the number of units that pass or fail an inspection or test is not the best or most powerful method of calculating process capability. And this is where process capability analysis comes in. It uses probability theory to calculate what is the probability of a product characteristic going outside of the customer specification. To understand how process capability analysis works, consider the two data sets here. These two histograms each visualise the weight of a cake in grams, represented by the grey bars, in relation to the customer requirement that the weight must fall between 198 grams and 202 grams, represented by the two lines. In both cases, we see that 100% of the cakes produced in these samples falls between the minimum and the maximum weight requirements. But both processes can claim, using percentage count, that their process capability is 100% good. However, as you see, this does not tell the whole story. Process 1 has much more variation in cake weight than process 2. We can therefore, assuming both processes are in control, say that there is a much higher likelihood of process 1 making a defective cake in terms of the weight being not enough or too much, compared to process 2. Process 2 is visibly more capable than process 1. But how can we put that into numbers? When assessing process capability, we need to use more than one metric to describe the process. A good way to understand the need for multiple metrics is to consider the different ways in which a process can fail to meet a customer requirement. There are 3 different scenarios here, which all show how you can have a not capable process. So we'll have a look again at the cake weight example. Firstly, look at scenario 1. In this case, the process variation is too large. Here the amount of variation in cake weight is wider than the acceptable tolerance limit of 198 to 202 grams, which means that the process is not capable of delivering 100% of the cakes within the customer's weight requirements. Now look at scenario 2. In this case, the process average is not properly centred. Here, the amount of variation of the cake weight is smaller than the acceptable tolerance limit. However, the average weight of the process is above the target weight of 200 grams. This means that the process is more likely to produce a cake which is too heavy and is therefore not capable of delivering 100% of the cakes within the customer requirements, despite having a relatively small process spread. Finally, look at scenario 3. The process average here is not properly centred and the process variation is too large. So here you see the spread is too wide and the process average is above the centre weight of 200 grams, meaning that the process is not capable for more than one reason. Over time, different capability metrics have been developed to cover each of the above scenarios. In the upcoming masterclass, we will cover how to calculate and interpret metrics for 2 of the above scenarios. Metrics which consider only process variation, commonly known as potential capability metrics, and metrics which consider both process variation and centering of the average. These are commonly known as actual capability metrics. In addition, for both potential and actual capability metrics, we'll also differentiate between what is known as short-term and long-term process capability. We'll explain this a little bit more in the next slide, but in general terms, this relates to the way that the process variation is estimated. So far, we've seen that there are 2 factors that can be taken into consideration when calculating process capability: the amount of variation or spread in the process and the location of the average in relation to the centre of the process. The other thing that you need to take into account is how that variation or spread is actually calculated. Process capability can be calculated using either short-term or long-term metrics. The difference between these two relates to the way in which the process spread of the variation is calculated. Short-term variation relates to variation that happens in the short term, for example, within the period of one day or one shift. We must be careful when using short-term data because it doesn't reflect all of the variation that exists within a process as process shifts and drifts over time. And you can see that in the diagram here. In this illustration, we can see how a process may change slightly from one time period to the next. These changes could be due to variation, for example, in machines, methods, materials, operators, or environmental conditions over time, and they're to be expected. If all the data is combined, then the longer term view gives the complete variation in the process. This is known as long-term variation, and it takes into account the overall process variation. So, in summary, we will look at capability metrics for both potential capability, that's when we just look at the amount of variation or spread in a process, and for actual capability metrics that consider both process variation and centering of the average. We will also consider, where appropriate, both short-term and long-term capability metrics, depending on how that spread has been calculated. The metrics that you see here are the ones that are most commonly used, certainly within manufacturing companies. These are CP and PP for potential capability, and CPK and PPK for actual capability. And in the upcoming masterclass, we will look at these in more detail and understand how they are calculated. It's also worth noting that if you don't work in manufacturing, if you work in a business environment or research environment, for example, it's perhaps less likely that you will see these capability metrics used. It may be that in your organisation, you simply use percentage right first time, or parts per million defective, or possibly the sigma level. We'll talk a little bit about those in the masterclass as well. But even if you don't use the metrics that you see here, it's still useful to understand the theory that lies behind how capability is calculated. So in this module, we've given you a definition of what process capability means, as well as introducing to you some of the other definitions around the theory that you'll learn more about in the classroom behind how process capability can be calculated. We've also revisited process control, which is a prerequisite for calculating process capability, and reminded you that process control and process capability are two separate concepts that should be measured and understood separately within your process. We hope that this helps you prepare and better understand the calculations when we get into the masterclass.